Hi guys, welcome to Techogenius Academy. We are industry-led training providers for those who wants to build their career in data science, analysis, IoT, device driver, embedded Linux and many more. Please do like, share and subscribe to our channel.
Hello everyone, welcome back to the Techogenius Academy. So we are back with the bang, and we are now discussing the Linux platform driver. Yes, so many guys requested we need some advanced session in Linux device driver, if we want to write some driver for our BeagleBone Black or any board, specifically where you can write the drivers like iSCSI driver, SPI driver kind of thing. So in the last session, I have explained you about the Linux device tree. So what are the different components? Actually, it's a data structure. So what are the different components are available in that Linux device tree structure? And I've showed you also from where you need to deep dive if you want to study more. So I showed you that path also. So in this session, what I'm gonna teach you guys, so it's like a Linux platform driver. So how we can write the platform driver for our BeagleBone Black. For that we will write one driver, and later on we will write one node in the Linux device tree which will bind the driver, so which will talk to that driver. And later on, to test that driver, we have to write the test application, correct? So we'll write some test application to check how we can write the data to that driver and how we can retrieve that. Okay, so without wasting any time, let's get started. I'll just do some introduction. So these informations are readily available over the internet. So I just collected all the information. So just for your understanding, but our main goal will be just to write the driver and test that driver by writing the application, the test application. So first we will go for understanding of the platform driver. So as you can see that platform driver are responsible for handling the platform devices, and it provides a mechanism to notify the kernel that of available hardware on that board. Okay, so before going to this understanding of this platform driver and these structures available over here, I just want to explain you one stuff. Suppose if there is some devices which is already connected, or which is already present in the BeagleBone Black, for example USB, PCI bus. So that will easily connect to the CPU and do that work now. If we'll talk about iSCSI, if we'll talk about SPI, so that is not present, that hardware is not present in that BeagleBone Black, correct? So for that, how we can do such stuffs? So for that, the platform drivers will come into the picture. So there will be a particular bus which will help us to talk to that particular hardware. So as you can see here, it's saying it provides a mechanism to provide the kernel of available hardware on that board. So that hardware is connected to the BeagleBone Black. So it will help you to communicate with the particular hardware. So the mechanism to add that device to that device model. So everything, whatever we are you can say whatever we are writing the driver and all, so this is based on the Linux device model. Okay, so which is of the kernel. Okay, so the mechanism is to add that device to that device model of that kernel, which is not present. Okay, so it is used for non-discoverable device and to have that compatible with the Linux device model, we assume that these devices are not these devices are connected to some virtual bus which is not present physically, and that bus is a platform bus. Okay, so there are two components of platform device driver. One is like, as I already said, that platform driver, which will do some set of operations on the device, and other one is a platform device which is connected to that platform bus. Okay, so the registration is done by there is a one platform driver structure which we will include in the driver, from where we need to call the prop call, remove, shut down, suspend, resume. There are multiple things available in that platform driver structure, but our main goal will be to concentrate on probe and remove. Okay, so the next thing is like how we can bind the driver. So before doing that, when we are initializing the module, we need to register the driver, and how we can register the driver, where we need to use the platform driver register call. Okay, and we need to pass that platform driver structure. So now that what is that platform driver structure? So as you can see in that static structure platform driver sample PL platform driver, so in which the probe and remove call is there, and there is a driver name is there, and the off match table which will help you to this off match table, which data structure which will help you to connect the connect to that Linux device tree. Okay, so there is a platform device ID. First one is the name and the driver data. So these structures will help you to bind the driver with that particular device. Okay, now to read the cell value, how we can do that, using this int of property read underscore u32. So using that we can read that value. So if we want to read the value of that particular cell. Now how we can unregister in the platform driver, as you can see here, is platform driver unregister. So these are the call which we need to use in our platform driver. Okay, so now there is one other thing also in the probe function. So the driver's probe function can be called with the new devices. Okay, so that function gets as an argument as a platform device pointer describing the device to be initiated. So there is a platform device structure which will have multiple members like dev resources. In that the resources will be the main thing in future. Like if you want to get some you can say some resources or some memory mapped or some registers and all, so you can use that platform platform underscore get underscore resource call to get those resources or register values. Now what to expect? So we'll directly jump to that GPIO based platform driver. So we will write one LED driver, you can say GPIO based LED driver, and along with that we will add the node in the device tree to bind the driver, and we will write the GPIO test application which will communicate with our platform driver. Okay, so can we just go and open the terminal? Yeah. So first we will go to that platform driver. Actually the thing is, I have already write one template for you, because as you already know about that character driver and all, so I'll not explain you this device class stuff and this class, that file operation structure and all. So if you don't know about that, I must say, like, go to the other videos, other sessions where I have already explained that how we can write the character device driver in advance. Okay, advanced character device driver I already showed you. Okay, so now the first thing is we will go to the template and we will write the things like of initializing the stuff and all, so that will be fun. Okay, so vi platform.driver.c. so this is the exact template. So I'll just directly go to that sample init GPIO module, and here I will just print something like print k, just to get those information that it's present, it's like in the initialization module. Welcome to the, okay, so can we say like this? Okay, welcome to the sample GPIO platform driver. Okay, and now what we need to do, register the platform driver. Now we have that structure sample underscore pl platform driver. Okay, this is it. Now we need to clean up also, we need to unregister also. First we'll just print something. Exiting the sample platform driver, thanks. Okay, now unregister the platform driver. Okay, platform driver unregister, and we need to pass the structure. Okay, cool. Now we already written that macro for that, which will initialize or exit the module, and now we will probably write our sample PL driver structure. So we need as I have showed you in the presentation also, so we need to include, because like main probe and remove call we will use here. So sample drv probe remove sample drv remove driver equals to, the name of the driver is sample PL driver, so that I have already written the macro for the same, and I need to add the data structure where we will add the compatible string which will match with the platform driver. Correct? So that structure is GPIO LED device tree. Okay, now this looks good. Okay, now what we need to do here, we need to add the compatible string. Sample GPIO LED. This looks good. Okay, so now what we need to do next, as you can see here in the probe section, I have already like allocated the character driver region, where, and after that I have created the class and the device also, and whatever the file operations I have to do, I am doing that. So these are the file operations. Okay, and this is the device creation, class and device creation. Great. So now what extra we need to add it here? So we need to add the of underscore property underscore read 32. So we need to add that to get that LED number. Okay, so how we can do that? First, so as you can see that the argument is the platform device. We will use that. The first parameter of that of property reads under U32 is NP. So I'll just initialize like that only, pdef, and we will get the node. Okay, so just to get the cell, here I will just say con alert in probe function call. Okay, so probably I will call the cell. I'll pass NP here, and that LED number I need to pass. This I will add it in the device tree, and the GPIO number, which is I have just initialized to 0. Okay, so this is great, and rest of the things we already written that. So now there is a file operation structure to open, to read, to write, and to release that. Okay, so how we can write? Suppose we need to write anything works here is like in a binary, like if 0 it's like we just need to turn off, and if it's 1 we just need to turn on the LED. Okay, so let me just call here first copy from user, and we will get that buffer, and after that we will use this you can say the switch case, where if we'll get the 0 we will just set the value to 0, and if it's 1 we will just set the GPIO number to 1, and if it's some other option so we will just say it's a wrong option. Okay, so for that I just need to take one temporary variable, and I need to call copy from user. I assume that you know about copy from user and copy to user. Just make a note for that, because this will be definitely be asked in the interviews. I have asked so many times to guys. And later on they will probably ask like why we are using copy from user, copy to user, why we can't use mem copy, or why is the need of this stuff, is there any other thing we can use? Yeah, you can use. There is a concept of DMA you can use, which will directly talk to that memory using the DMA controller. So there are multiple stuff, you just need to focus. Okay, so now we need to do the switch case. If it's 0, we are just making it as a 0, and if it is 1, we are just setting the value to 1. Okay, and if it's default, if it's some other option, we just need to print that wrong option is entered. And we should break, and we will just return the count here. Okay, so this is pretty much good. Now how we can read that? As you already know that we need to read it from like copy to user. Okay, so to get that value, like now we are setting the value, now we need to get the value of GPIO. Let me just use the GPIO get value. I need to take an same temp variable here. I'm using copy to user. Okay, so this is it. We have successfully completed the platform driver. It's just simple. We have written the makefile also here, and this is the makefile. I'm just adding into the kernel source. Let me just run make just to check. Okay, there are few stuff. Okay, let me just solve this. Okay, so it's done. Now the next thing what we need to do here is we need to add the node in the Linux device tree. Okay, so how we can do that? we need to go to that path. So the first thing, like, I just want to ask you, what is that actually path? That path you need to remember. That path is arc, arm, boot, DTS. So that is the path. Let me just go there. Arc, arm, boot, DTS, AM335X, bone black dot DTS. Okay, so I've just added some SPI driver call, so don't mind about that. My LEDs compatible sample GPIO -LED LED number is 0x38. Okay, so this is the LED number. So this is it. We just need to go to that and we need to do make TTPS. Okay, there is some error. Let me just go and check. Done. Now what we need to do, we need to transfer this into that BeagleBone black. Okay, one second. First, what we will do, I just need to connect that BeagleBone black also. This is done. So first we will write the test application also, then together we will just transfer those files, correct? So to do that, let me just create one apps folder here. Okay, so now what we need to do here, we need to write one test application which will write to those GPIO pins. Okay, so how we can do that? I'll just say some GPIO platform. Okay, so I'll just can I just say platform driver test. This is cool. Let me just include some of the header files here. I'll not take much time if I'll not do some silly mistakes. Okay, so now what we need to do, we need to say, like, if we need to get the status of that particular LED, if we want to set like if we need to set the option, like if the LED is off, if you need to turn it on, how we can do that. So these are the some stuff we will do. First of all, we will open the FD. Okay, we will open the file which will give you the file descriptor also. Okay, So how we can do that? Using open call. Fd equals to open. The path is /dev GPIO. Let me just, I can just show you also. Okay. So as you can see here is, when we are creating the device, I'm just putting GPIO underscore DRV and the number is 0. So the GPIO underscore DRV 0, we need to pass it to that file name. So let me just write down here GPIO underscore DRV 0. Okay, and we just need to open it in read write mode. Great. I'll just mention the error case also. We can say just LED operations open. Okay, so now we need to use the switch case. So here we need to mention the option. So int option, we can say here is okay. Let me just take one do while loop. If I can say here is okay. First option is getting the LED status. Printf. Second option is setting the LED status. Okay, and we can use some close also if we want to close it, or if we want to exit, just we will press 0 option here to exit. Now we will just enter your option. We'll just scan. We'll just some get character, get char. We'll use now switch case. Now if that case is if the case is 0, we just need to break. If the case is 1, okay, we just need to declare one count here also. So int count equals to 1. So first we will just check like if fd is equals to -1, we'll just say file not open, and we will just do break. If this is not the case, we will just read the file descriptor and I'll just take one character also, unsigned character C. Okay, so what we are reading here, okay. Now if the count is equals to -1, we will just say p error led operations read. We'll just print the error, else we will just print the value. LED value is %T, C. Printf /n and break. Okay, now if that case is we have used 0, okay, we getting the LED status. Okay, now if we need to set the LED status, if the state now the case is 2, so how we can do that? Okay, now printf enter your option, zero, turn off the LED, comma 1, turn on the LED. Okay, we just need to get the value. Count, we just need to write fd comma address of C, simple C, if count is equals to -1, p error LED operations right. Then break. Okay, now we need to come also outside and okay, now if we need to close, so how we can close this? Best just do okay case, okay case, okay 1 second, case 2, okay case tree close of file descriptor fd equals to -1 and break. Understood? And for default we just need to say here invalid option. Break. Okay. Now here we just need to mention that while option is not equals to 0, and here we will just return 0. Okay, so this is the test application I have written. Okay, and we need to mention one IOCTL operation also. So how we can do that? Let me just include the IOCTL operation also. Header file hash define GPIO select LED underscore IO write print. Okay, so this is the macro here, and let me just write the make file also just to run this. Or what we can do, we can just okay, we need to cross compile now. Vi make file cross compile Linux hyphen GNUEABIHF cross compile GCC srcs source wildcard star.c tgts dollar wildcard, or you can say no need to write also, just add the source here only. .c equals to okay. Now we just need to add here so we are cross compiling this application for our BeagleBone Black now, so we need to write like that. This is the generic one. whatever the file you will write, this will give you the executable. Unsafe thread unsafe .c dollar LP thread for clean dollar RM dollar TGTS. Correct? That's it. Okay, case 0. Make done. So we got the executable platform driver test. Okay, now let me just connect my BeagleBone Black. Just give me 1 second. Okay, so we have connected our BeagleBone Black here, and let me just go to okay, so let me just up my IP, and I'll just transfer my DTB file. Okay, and the mount underscore boot I have already done, so I'll just reboot it. Okay, and now let me just go to the platform driver and let me just transfer the platform driver also. Okay, and the application also. Done. Now we will test this. 1 second. This is not connected. Okay, so let me go to that BeagleBone Black. Okay, so I have transferred my DTB file over here. I rebooted it. I have transferred my platform driver also. Now just let me know if you can see this. Okay, yeah, welcome to the sample GPIO platform driver pro function call. Major number is 240. Now if we'll check the device file also, it's there. This is the beauty. Now can we just run our test file here? Okay, so we are getting the option like getting the LED status, set the LED status, close, exit. We will just enter the option 1. The LED value is 0 now. Now I have connected my BeagleBone Black. Now the LED is off now. Let me just set the LED status and check the LED will on or not. 1. Yes, LED is on now. If you want to check, like if you want to confirm, like I can see, I can just can't show you that the BeagleBone Black. I can just see that LED is on. Now let me just run the getting the LED status again. 1. See, the LED value is 1 and I can see that LED is on. So in this way, what we understood, like how we can write the platform driver and how we can test that driver using that application. Okay, so we'll just exit it. Okay, so this is it. So this is the great understanding of the platform driver. So hope you like this session. I just want just to go to that channel and just subscribe it. So because as much as you will subscribe, from my side you will get more and more sessions in advanced Linux device driver series. So thank you so much. We will touch base in the next